Yeah, friends, very good morning. In last class, with respect to electric field, we have introduced the electric field due to a point charge and electric field due to a dipole. Also, we have introduced this concept of dipole and the terminology such as dipole, dipole moment, axial lines, equatorial points. And the previous session, we have dealt with finding intensity at an axial point. So today, we shall continue our work with the case of dipole, and in the same session, we'll be dealing one very important concept, right? So let us begin with our class today. Electric field due to a dipole at an equatorial point. So one more time, let us consider a dipole of length 2a and a dipole moment small p, right? Here I have shown it, such that now this time p is an equatorial point at which now we will find the intensity of that electric field. Now here first let us show whatever geometry is there, right? What is that? First one is AB, the length of the dipole, which we have taken a symbol 2a. Yes, 2a for that convenience, mathematical convenience, that if I want half of that distance, it becomes a. For that reason, it is taken as 2a. And now OP, the distance of the equatorial point. Distance of equatorial point, of course, distance always the center of the dipole. Therefore, this distance OP is, I will take it as small r. OP distance is taken as small r. Therefore, naturally, what is this AO or OA is equal to OB? OA is equal to OB is equal to A. And one more geometry. Now, I will join the charges and the point P. Here you will find plus Q at the position A and minus Q at the position B. Therefore, now I am taking this distance. Therefore, here the symmetry will tell you that AP is equal to BP, because any equatorial point equidistant from both the charges. AP is equal to BP. Therefore, what will be this one? This is AP is equal to BP. Right angle triangle you will get. You will see that right angle triangle hypotenuse. Therefore, this is nothing but the root of R square plus A square, right? So this is what is the geometry, and still we need some more geometry. At this moment, let us take this geometry. Now, what is our step process to find intensity at any given point for discrete charge systems? Yes, consider a test charge at the point of observation. Therefore, now imagine a test charge at Q0. Therefore, now I am imagining a test charge Q0 at P. This test charge will now experience two forces. This test positive charge, repulsion due to plus Q, but attraction due to minus Q. So one more time, we have to show those two Coulombic forces on the test charge. Now, how to write that Coulombic force as a vector? Along the line joining. Therefore, here you find, I will join A, P, and along this line, you have this vector. So vector I will show it with a different color. Vector I will show with different color. Yes. So this is one of the forces. This force is force due to plus Q, which is the repulsion. Now Q0 experiences attraction due to this minus Q0. So first show the line joining. This is the line joining. And now what is that vector that I am showing? So this is what is the vector that I am showing again with a colorful vector I am showing you. This is what is the other vector, force due to minus Q, force due to plus Q, and force due to minus Q. So these are the two forces. And now here a simple geometry also one more time. Supposing if this angle is theta, this angle is theta, this is what is the exterior angle, is it not? This is the exterior angle. Therefore, this total angle becomes 2 theta. Because exterior angle, sum of opposite interior angles. And as you know that this is an isosceles triangle, because these two you can see that symmetry, right? Isosceles triangle. So now, this is what is everything about finding intensity at equatorial point. Now what follows is a very simple common sense. Remember, practicing this is what is essential, not only for board examination, even for the complete understanding of the concept, any of such things. This is what is the physics part. Look at carefully where we have began with step 1, 2, 3, 4. That is what is an important thing. So first we have shown the dipole, then this equatorial line. At this equatorial point, a test charge. Then whatever geometry is there we have shown. And most important thing, we have drawn these forces as vectors. Now let us write those two forces, and finding the resultant force is what is just a simple common sense that has remained now. So first let us see that. See here, what is the force due to plus q? These are q and q naught. Distance is what is base root of r square plus a square. Similarly for this pair q naught is also same pair and same distance. Though, and hence these two forces are having same magnitude. They have same magnitude, right? They are different directions they are acting at, but both have same magnitude. That is what I am writing. So force due to plus q, this magnitude, is equal to force due to minus q, right? If I am representing them as vectors, the magnitudes are same, and I consider that as f. Now what is the f? Yes, once again, 1 by 4 pi epsilon naught q1 q2 by r square. Therefore q naught. One of the charges is q, other charge is q naught, the pair. And what is the distance between them? Distance between them, already you got right, q naught by what is the distance between them? Yes, this is root of r square plus a square. Therefore when it is squared, you will get r square plus a square. R square plus a square. And now what is the angle between the two vectors? Yes, angle between f1 bar and f2 bar. The angle between them is 2 theta. Angle between them is now two vectors, and the angle between them. Therefore we will get the resultant by using yes, root of p square plus q square, the same expression we have been using. Remember, the same job is now left over. Now, what is that you get? So this is a net force is equal to root of p square means f square, magnitude, q square, same magnitude, f square plus f square plus 2eq also will be f into f square. And this is cos. Look at the angle between the two vectors here that is shown. Angle between the two forces is 2 theta, where theta is shown in this geometry. Please do remember, when I have told this is everything, now you look at this and substitute here. And don't say that it's a confusion, because it is there in the figure clearly, that is therefore it is cos 2 theta. So this is f square plus f square. 2f square. This is also 2f square. Therefore, one thing is common. Therefore, I am taking it as yes, 2f square common. It will be 2f square common 1 plus cos theta, cos 2 theta. 1 plus cos 2 theta. And now, what is this 1 plus cos 2 theta? Yes, it is 2 cos squared theta by 2. Since this is 2 theta, 1 plus cos 2 theta is 2 cos squared theta. 2 into 2, 4. Therefore, final result I am writing is 2f cos theta. 2f cos theta is the resultant force. And now, let us come back to our result picture and let us show where is that resultant vector and how we are writing that cos theta. Now here you see these two are two vectors with equal magnitude. Two vectors with equal magnitude, therefore the resultant is always along the angular bisector. Right? This has been used several times, and I repeat one more time. In the case of two vectors of equal magnitude, the resultant is always along angular bisector. Therefore now this is what is the angular bisector that you are getting. So this is the net force. And look at this vector. This net force is now parallel to axial line, right? This is parallel to axial line from plus q to minus q, and that is what is our direction, right? Now this is what is the net force we got. And one more time, how to write cos theta? Again here in the geometry, one more time, you please write cos theta also. What is the cos theta? Yes. In this figure, cos theta is adjacent side by hypotenuse. Adjacent means, yes, OA by, yes, it is AP, and which is nothing but A by root of R square plus A square. You remember cos theta we have taken here? That will be substituted. Value of F and cos theta to be substituted. See, this is how you follow the derivation. Nothing like a memory, because everything will be there in that figure you call, I call it, it is what is physics. You can write the notes, you can make your derivations, everything. Therefore, regarding any of the concept, when your teacher gives you a figure, you first practice that, because that happens to be physics or chemistry or biology, not the English part. That you can do it afterwards if you understand and practice this periodically, right? Now, let me substitute that. What is that net force? Net force, this is 2F. Let me write it 2 times. What is the F? Q naught by 4 pi epsilon naught is already there. It is R square plus A square times. Now, cos theta is A bar R square plus A square under root. Under root means I will give a power half. The index half. Is that okay? It is under root R square plus A square. And here a small rearrangement one more time. What is that? What is that? Q naught times numerator 2A, and this is what is Q. Q naught, rearrangement of terms. 2A I have taken times small q by, yes, this is 4 pi epsilon naught. This is R square plus A square, and it is, yes, A power x into A power y, A power x plus y, right? A power x plus A power y, A power x plus y, therefore this is R square plus A square, yes, it is 1 and 1 by 2, therefore it is 3 by 2. So this is what is a small derivation. Maybe some of the time you may feel it a lengthy derivation or difficult derivation, and nothing like that. Please see one more time. You have to draw a beautiful figure with understanding. 2 vectors are shown. Those 2 vectors having same magnitude because of symmetry. Writing that vector and the angle between them is also shown in the geometry. Now finding that resultant vector, same parallelogram law, vectors addition we have taken, a small simplification. This is what is F net. So in our immediate next step we will have our answer. Because remember, this is all we have calculated about the net force. Now we have to write it for the intensity at the point P. Now let us see that expression in our last step. Yeah. See, this was net force. Now use your definition. The definition of intensity at any point E is nothing but, yes, the force experienced by test charge. Therefore now you are doing this net force upon this test charge. Therefore this Q naught gets cancelled. And now what is this 2A times Q? One more time. Dipole length and one of the charge. That magnitude is what is dipole moment. Therefore our final expression is E is equal to 1 upon 4 pi epsilon naught. This term is small p, dipole moment. And look at this term, this is R square plus A square whole rise 3 by 2. Yes, this is the required expression. This is the required expression. Now, look at the direction. You please mention that direction. Without the presence of direction, without this as an imprint, whatever you remember, it will be of no use. Maybe for board examination, you may be able to write 1 or 2 answers. But if you want more, If you feel a dil mange more, this is what is to be your, not memory, I am again telling you, this is should be your understanding. At any given point of time, you should be able to draw this geometry, this physics. Then automatically the nodes and the derivations, and even this does not become a memory then. It will be like a flash memory that will come to you at any required time. So now what is the direction you will find? This is, yes, parallel to axial line, from plus q to minus q, from plus q to minus q. This is what is the direction. Remember yesterday we told about intensity at axial point. It was along the axial line from minus q to plus q, and hence we said it is parallel to p bar, dipole moment vector. But now what about this case? In the case of equatorial point, what you find is that, yes, equatorial vector is opposite, they are anti-parallel, opposite to p bar. The angle between them is 180 degrees. In the case of axial point, the intensity vector and dipole moment vector. So parallel vectors, angle between them is 0 degrees. So these are all very important things that you have to make, and again, you have your notebook. You try to present whatever your understanding is there in the book. That's most essential part of your practice and preparation. Not only with respect to physics I am telling you, but with respect to any of the subject. Once you go through the concept, what is your understanding? That understanding you try to keep it on the paper. That will help you a lot again I'm telling you. So now, once again, last class we have told E at axial point. Now this time it is E at equatorial point. What about short dipole? Yes? Yesterday we told what is meant by short dipole. In the case where capital or distance of the point is very much greater than the length of the dipole, for such cases we have neglected this a square term compared to r square. Remember that we did yesterday? The same I will do now. Therefore, short dipole, because I can definitely say, looking to the previous history of any of the examination, 99 point, if not 100%, we are always asked with the case of short dipoles. Therefore now, for a short dipole, E, yesterday, axial, one more time I would like to remind you, it is like you got 2kp by r cube, of course the direction, parallel to theta. Now here, what is that? E equatorial. Here if a square is neglected, this is r square whole power 3 by 2 becomes r cube. This 1 by 4 pi epsilon naught, the same k I have taken, right? So this is what is k p by r cube. E equatorial, short dipole, k 1 by 4 pi epsilon naught times small p by r cube. Now these are the two important results. And now first, after all this kind of derivation part, now let us focus on this result. And what simple things that we can find, we will make a point, right? And even before that, supposing you will get a doubt, sir, we have discussed it for the case of axial points and equatorial points. What about any other point other than equatorial, other than axial? Supposing I consider a point somewhere in between, what will be the case of intensity? That also a kind of a rational doubt if someone of you got. Just let us also see that one also in our next stage. See the dipole, a point, a general point, not an axial point or not an equatorial point, such that, look at this angle, this is a point which is making an angle theta. This line joining the point makes an angle theta with axial line. Whenever you write angles anywhere, simply don't say theta is angle, alpha is angle, phi is angle. But what is the definition of angle is very, very important. Now here the theta is not angle. It is angle made with axial line, right? In such case, I will give you a result. And if anyone wants, sir, how come that result may be a kind of curiosity, at least for few students, then anyways you have the contact number of all your teachers. Yes, you can call them. You can even, you are at your liberty to do any video call also. One or two students, I was very happy. they called me through video and they just clarified some of their doubts. Okay, now I give you an expression. If you want anything more than this, you can have a personal contact with your teacher. Now, E at point P, again I am telling you, this we are writing for short dipole, not for dipole in general, but it is only for a specific case, that is short dipole. EP is equal to, of course, this 1 by 4 pi epsilon naught, which I keep calling small k, right? 1 by 4 pi epsilon naught. In fact, this is a let small p. P for dipole moment. P by 1 by 4 pi epsilon naught times r cube. R cube. Now here comes another part of this expression. It is 1 plus 3 cos square theta is the expression. And now this, suppose if P is an axial point, then what about theta? Theta becomes 0 because the angle is with respect to axial line. So for an axial point, the theta becomes 0. Then whole this term will be the same again, 2kp by r cube that you will get. And for equatorial point, you will get theta is equal to 90. Again, this term becomes 0. The same condition or the same result that you get, kp by r cube, like that. And now, when we look at these two things, let us write important things. First one is that for short dipole, all these results, please do remember, we are writing for short dipole. For short dipole, one of the important results is E proportional to 1 by r cube. Yes. For point charge, we have seen E proportional to 1 by r square. For dipole, it is E proportional to 1 by r cube. Any change of distance and the change of intensity, it is inverse and cube, remember. Yes? And of course, the same what we might keep on telling, E1 by E2 is inverse and cube. This is what is R2 by R1 and everything is cubed. So this is one important result that I take. Afterwards, one more important thing. So this is number one. Number two, earlier we have said that E axial is 2kp by r cube and E equatorial is kp by r cube. Remember this E proposed to 1 by r cube for any point, not just equatorial or axial, any point, right? Now look at these two equations. What is that we get? Supposing here again r axial and this is what is r equatorial, it means actually I didn't take. Now from these two expressions, right, what is that you can see? Even before I tell you something, you observe and you just try to focus on some of the small changes in the expression. Kp by r cube is a common term. Now when you look at these two, you have this expression. This number 2 is, yes. Therefore, now I am writing. That is, if r axial is equal to r equatorial, that is you are taking 2 points which are equidistant. One at axial point, another at equatorial point. In such case, what is that? Remember, if r is the same, what is the differentiating term here? It is only 2. Therefore, if r axial is equal to r equatorial, you have E axial is double E equatorial is one of the important results that follows. Right? E axial is equal to 2 times E equatorial. Right? When is it? When 2 points you have considered, both are at same distance from the center of the dipole. Right? Distances are same. Then intensity is more at axial point. For same distance case, more intensity at axial point, and how much it is more? It is more by 100%. Double means it is more by 100%. Similarly, I can go on adding few more also. Just now look at one more time. I said that distances are same, this is what is the intensity. Well, suppose you thought that, sir, what happens? Suppose if I say E axial is equal to E equatorial. Suppose at 2 points, one at axial, another at equatorial, intensity is same, then what happens? The distances, what will be the relation? Distances, what will be the relation? Shall I write it? Because you said both are equal. So now let me write that. If E axial is equal to equatorial, then I am writing this is 2kp by r axial cube. Because this time remember, intensity same means distances cannot be the same. Therefore I am writing E axial is equal to skp by r equatorial cube I am writing. Supposing if I am writing capital A for axial and capital E for equatorial like that, then what is that you get? Common terms are cancelled. So here what you get is RA cube is equal to 2 times RE cube, right? RA cube is 2 times RE cube. Therefore if I am taking the cube root on either side, cube root by 3, by 3, by 3, right? Cube root if you take, yes, what is the final result you get? R axial is cube root of 2 times RE, cube root of 2 times RE, that is distance of R axial. Mean axial point is at more distance when intensity is same. RA is more than that of RE, 2 power 1 by 3. This number also I am telling you, you write it, let me not do it. Supposing you got that number, how much it is more, where it is more by 30% or 20% or any other number, you look for these two things, right? Now, let us continue more about the same concept of dipole. See, I am telling you, I am just not doing two derivations and leaving it. After doing the derivation, the most important thing is how we observe and understand and digest the concept is very, very important. Any subject. Remember, if I am doing dipole, concept of dipole for at least 1 hour, last class we spent some time and maybe today also, as much as till now 1 hour of discussion on dipole by the teacher. What does it mean? If it is 1 hour discussion by the teacher, certainly it should be more than 1 hour practice by the student. Sorry, Vidyarthi. I have told you too much of difference between student and Vidyarthi. Who is student? Who is student? You remember I have told you? It's a technical term in English. Whoever attends college by force or by interest, doesn't matter. The one who attends the class, college and do of course his own whims and fancies, you can call him student. But what is Vidyarthi? One more time I remind you. Vidya plus Arthi, Vidyarthi, Savada Dirgha Sandhi. What a great word in Kannada you see. It's not a technical term. Vidya plus Arthi. Vidya Bedkodonu. Vidya Bedkodonu Vidyarthi. And what will be the difference between student and Vidyarthi? Not, of course I have told you kind of literal meaning and technical difference. But the difference between the two you will understand in the month of March and April. When actually the people face the challenge, that challenge what you call your examination, any of the examinations starting from your board examination or even before that your practical examinations, any examination, afterwards what follows your competitive examination, yes, there comes in this difference. If this is what is Vidyarthi, this will be student. They will feel, they will do all sort of drama-bazi with the parents, with the teachers, with the society. In fact, leave all of them. They do a lot of drama with themselves. And that is why, number of times, actually as a teacher I should not request you, I should demand for you. But still, due to our admiration for all your parents and for the happiness of your parents and families, I am requesting you one more time. It is to be Vidyarthi, not a student. Even now also, it is a virtual class, you are sitting with a kind of system in your hand, in your palm. And don't make it as a kind of formality. You see. This is a very important time to know what you are. Because when you have this freedom, again one more English word, freedom. What is meant by freedom? Doing our own choice, is it not? According to English, but again come to Kannada, the Sanskrit word. What is that? Swatantra. What is meant by Swatantra? Tantra means governance. Swatantra means self-governing. Swatantra means not doing according to my whims and fancies. In fact, Swatantra is, yes, self-governance, how I mind myself, how I respect my time. This is what is meant by Swatantra in Kannada. So I wish, because you now are at your full freedom you feel, but I will tell you it is not freedom, it is Swatantra. So in this Swatantra, you come to know what category of person you are, or me for that matter, anybody. We come to know this is the time what is our true character, whether we have that respect for our time and do Kayakvai Kailasa, or simply find reasons to escape. And I wish all of you should be the proud Vidyarthi of KCS, and because of you, all your families should be so happy. At least your parents should be very happy because of you. So as I have told you, 1 hour by teacher, it should be at least 1.5 hours from your side. Again and again I am telling you. You do that practice in the writing form, you will find all that advantage. Now let us talk something more information regarding this dipole. Electric dipole, intensity at a point. What is the magnitude and how to represent the vector? Now that clear. Now you see. You just think of a case like this. So this is a short dipole. One more time, short dipole. And P is an axial point. Axial point at which intensity is given, number or symbol. Supposing he says at the point P, the intensity is some x units number or symbol given to be some E or any other number. Supposing at this point P, look here, where is this point P? This is nearer to negative charge. Any axial point will be closer to one of the charge and will be farther to the other charge. We have told it in the very beginning. At this point P, suppose he says the intensity is 10 units. Intensity is 10 units. Okay. Nothing said more than about that. He said 10 units. And now this dipole is rotated about its center by some angle. At least for our needs, we take that number theta as 90 degrees or 180 degrees or multiples of 90 degrees. Now we said that the dipole is turned again clockwise or anti-clockwise. That is also an important term that we should find in the data if given. Supposing I said it is rotated 90 degrees clockwise. 90 degrees clockwise, what happens to the intensity at the same point P is a question. Shall we do it? Now initially at P, first let us write the data. At P, E is equal to 10 units. 10 units, this is before rotation. Now isn't it is rotated about its center and clockwise 90 degrees. So this is the center if I locate. Now turned clockwise 90 degrees. 90 degrees means, now you write the new position of the dipole, 90 degree rotation. Okay, let me show it with another color. This is what is the new position. 90 degree. Now I am writing with this red color. This is what is the new position. Therefore again one more time you show this. This is what is plus Q. Yes, this is what is minus Q. Rotation of 90 degrees. Rotation of 90 degrees about the center. Now what is that you will find in this a change? Now you see the same center. Now this point P has become equatorial point. Earlier it was axial point. Now when magnet is turned by 90 degrees clock or anti-clockwise sense, the axial point becomes equatorial point, and similarly if it were equatorial point, it now becomes axial point, vice versa. But no change in distance. Axial point becoming equatorial point or equatorial becoming axial point without any change in distance because it is rotated about its center and the distances are always from the center of the dipole. Therefore, after rotation it becomes, so again I am writing you, after rotation E dash is equal to, now we will use that result and we just now have told that distance same, axial point and equatorial point, what is the relation that we have given for the intensity? Yes, axial point is double that at the equatorial or equatorial half that at axial. Now since axial has become equatorial, what happens? E dash is equal to E by 2, that will be 5 units. Right? So this is what is the change that happened due to rotation in the magnitude. Along with the magnitude, remember there is a change in the direction as well. How? Again, one more time, write the vectors. Earlier, let us write these vectors. What is the given? It is 10 units. If you write it as a vector, this is point B axial needle to negative charge. Therefore, this is the vector that you, this is the vector towards. Therefore, I call this vector as E bar before rotation. Now, after rotation, let us write one more time. Let us write one more time. This E dash, E becomes E dash. How? This is become positive and this is negative at this point P. Along the axial, parallel to axial and from positive charge to negative charge, plus Q minus Q. Therefore, now this is what is that you get. I am writing this as E dash, E prime. Okay. Now, what do you find that? Now, again, this is a change of, yes, 90 degrees. 90 degrees, and the rotation is important here. How? This was clockwise rotation, and now here you see this is what is anti-clockwise rotation that you got. Also specifically, E bar more length I have shown and E dash bar I have shown lesser length. Again, magnitude has decreased and in fact it is higher. Is it not? Therefore I have taken that. Therefore now what is the answer? The answer is of course the magnitude 5 units and rotates by 90 degrees, yes, in which rotation you got? Anti-clockwise sense. In particular examinations like our competitive examination, this is what is the important. This kind of logic, that is what is important. Once I am clear with my common sense and the fundamentals, after that these kinds of small logical things, at least after your teacher speaks to you in detail and makes you learn, these things should be easier for you. Anti-clockwise rotation. Like this. Now supposing instead of 90 degrees, I said 270 degrees. Multiple, I am taking odd multiple. 270 rotation, supposing if it is. Then what will be the change you tell me? If it is 270, this is 90 plus 1 more 180, another half rotation. Therefore, plus Q will come to this position and minus Q will go there, right? So the change will be, this is what is plus Q and this is what is minus Q, and this is for a rotation of 270 degrees, right? 270 degree rotation. Then what happens? Again P remains as equatorial point, but what is the difference that you get? Yes, you will find a change in the vector. What is that? Earlier is plus Q to minus Q, you have taken this vector downward. Now you see positive charge and negative charge. Therefore now at the point P, the new vector I will write it as E dash. Then you will find this rotation is 90 degrees of course, but clockwise. 90 degrees of course, but it is clockwise. So whenever it is said that 90 degrees, the change of magnitude is there, and also rotation is in the opposite sense. Clockwise rotation of dipole, anti-clockwise rotation of intensity vector. Whereas for 270 degrees, yes, 270 degrees of clockwise rotation, intensity is held in the magnitude and rotation is 90 degrees in the same clockwise sense. So these are the small changes. They become like the toughest or very intelligent questions in our NEET or CET like examinations. Okay, see, supposing in the same example I said 180 degree rotation, dipole, not 90 to 70 but this time it is at 180 degree. 180 degree rotation, what is the change that you will observe? Yes? What is the change that you observe? Suppose it is 180 rotation. 180 rotation, the only change that you observe is that this becomes minus q and this becomes plus q. Earlier, the vector was, I will write it with green, this was E bar. This was E bar earlier, first one green. Now I will represent the second one with the red one. Now after 180 degrees of rotation, what happens? Now this is what is the vector that I show, which is in red color. What is your take from these two things? You tell me. 180 degree rotation, axial point remains axial point. Equatorial point remains equatorial point. Therefore, no change in the magnitude of the intensity. No change in the magnitude of intensity, but what you observe? The vector is getting reversed, therefore, no change, but the direction is simply reversed. Remember, most of the time some of the students will have this kind of thing. Direction is changed is different, direction is reversed is different. Because direction is reversed is a specific case of change. Therefore here 180 degree rotation, the vector is simply reversed, no change in the magnitude like that. So a concept was understood about the intensity vector, drawing the intensity vectors. Now it is clubbed with one such topic. Like this we can go on doing things there. We can go on adding many more things. But let us stop somewhere. Now I will switch from this topic to another topic. Again we will do a few more things with respect to dipole. But even before the dipole, remember we talked about point charge. So my next topic is again with respect to point charge. Whatever concept we have learned about the field vector. Now this topic may not be in your textbook, but it is a very important topic. In fact, it's a central topic. Central topic not only for this particular unit according to the NCERT textbook. It is a very essential concept in other parts of physics also. And that is why in your learning, in your understanding, let it be conceptual, not unit number 1, unit number 2. If you practice like that, it becomes a hindrance for you. Okay, now let us discuss about an important topic. I told an important concept. Remember, concept is a very new one and important one. It may seem, but again I am telling you, all those things which I am going to make use, you will find the same understanding of your first year physics. I have told you in second year, at least as part 1 is concerned, I never speak new physics in second year. All the physics already we taught it in first year, right? Now you can see, and I am giving a challenge. I am giving you a challenge. You find new physics at least one single day. You can call me. A big reward will be there for you. And again I am telling you, all these things that now I am discussing is not a memory. It is all your understanding of physics. Now what is that? I said charged particle in an electric field is it's open topic. Again we have number of cases that we will discuss. What is that cases? First I say a charged particle placed in an electric field. Placed means, yes, initially no velocity, right? It simply placed, released in an electric field is one thing. What happens? After that, the cases. The second case will be a charged particle is projected, thrown in an electric field. There again we get number of sub-cases, like in which direction we are throwing the charged particle, right? Different possibilities, because theta can vary, the direction can vary from 0 degrees, that is parallel to the field, to anti-parallel 180 degrees opposite to the electric field, or in between any other 60 degrees, 90 degrees, all such possibilities. Believe me, you can do all these things on your own. Here you follow those steps that I am telling you, right? Now, as I have told you, I have taken the simplest case to begin with the, yes, placed in an electric field. Now here some of the terms that I am using with their common meaning. What is that? A particle of mass m, charge q. Symbols that I am using: m for mass of the particle, q for charge of the particle, placed in an electric field. When I said, let us consider it to be uniform electric field. Whenever I say electric field, you take it for granted uniform, unless and otherwise I say non-uniform. And now this is an electric field, uniform, and the intensity is E bar. Okay, the intensity magnitude is capital E. Now this is what is the data here. Now placed in an electric field, then it means that U is equal to 0. Since it is placed, U is equal to 0. Now immediately, earlier I have told, whenever charge in an electric field, earlier I told Q1, Q2 interaction, we now stop. From now on, the discussion is field versus charge. So when a charged particle is placed in an electric field, you want me to show the diagram? Okay, let me show. So this is what is a uniform electric field. As I have told you, always represented by straight, parallel, equidistant lines of force. Need not be parallel always, any orientation. This is also a uniform electric field only, right? So anything, but the point is that straight, parallel and equidistant is the criteria. This is an intensity, capital E. Now here we have placed a charged particle. This is a charged particle whose mass m and charge q we have told U is equal to 0. So immediately use the definition of our field. Whenever charged particle is placed in the electric field, it experiences force. Because what is our definition? Remember, it is nothing but E is equal to F by Q I have told. But it is the same Coulombic force which is modified. Therefore, F is equal to, you write it as EQ. So charged particle placed in an electric field will experience force. Therefore, now force on the particle F is equal to intensity times charge. Since there is force, there will be acceleration. Here we are considering one and only force present, no other forces are present like gravities or any other forces. There are, if at all there, they are negligible or they are absent totally. Therefore, since there is force, there comes acceleration. The one and only tool for entire physics, the Newton's second law, right? F equal to mu we have given. So whenever there is force, net force gives us to net acceleration. Therefore, A is equal to F by U. Now you tell me whether it is a memory or your own understanding that you are writing. I simply said placed means U equal to 0. This is what is our new understanding in second year by the concept of field. F is equal to EQ, charged particle, electric field, force, and force gives rise to acceleration. Now the important thing is that whenever we are writing, remember all these are vector quantities, and this is where the smartness of the student lies. Right? What is the direction of F is equal to EQ or E is equal to F by M? Because now the charge can be either positive charge or negative charge. Now remember, we have defined the vector E bar with respect to test charge, which is a positive charge. So all those vectors that we have earlier and even in the coming days, whenever we write those intensity vectors, they are with respect to positive charge. So positive charge means the force F bar is nothing but in the direction of field. Therefore, for negative charge, the direction of force will exactly opposite to the electric field. Now look, that statement that we are doing. Since whatever may be the direction of force, the same will be the direction of acceleration also. Here comes an all important thing that I have mentioned now. Now this is F bar parallel to E bar for, yes, positive charge. For positive charge, it is along the field, force, acceleration, along the field. Now here comes, now for F bar is opposite to E bar. They are anti-parallel. Remember, I said F bar is parallel and F bar is anti-parallel. This is for minus Q, negative charge. Experience and accelerate opposite to the direction of the field. Therefore, if you are placing here a positive charge, what does it mean? Yes, it accelerates in this direction. Negative charge means it will be the opposite direction to the field. This is an important thing. May not be for our board examinations, for those memory answers, but if you are a Vidyarthi and you will always, your heart says Dil Mange Mo, then please follow these concepts and write them once, twice, thrice. For about 1 week you practice all these fundamentals. One more time again telling you, no new thing all these things, because these are the known things. We got force and hence acceleration. Now what is meant by acceleration? Whenever there is acceleration placed at initially low velocity, now the particle, yes, starts moving in straight line, whether parallel to the field or opposite to the field, depending upon the charge. Therefore it gains velocity. Therefore now I am writing the other aspects about the motion. See, this is what is physics. Whenever we say physics, any topic, there are the concepts of understanding of vectors I told, right? Then motion, then force, afterwards it is energy. So the same steps we are following. There you said earlier kinematics, dynamics, all those things, the same principles here also come. There is acceleration, therefore what you write? Now I am writing velocity. Velocity acquired, velocity gained by particle is my question. Okay. Now for that again, velocity whenever you are writing, we have two relations, velocity time relation, velocity displacement relation is there. So velocity time means v is equal to u plus at, u equal to 0. And a is equal to f by m, which is nothing but eq by m, is it not? A is equal to, yes, let me show here. A is equal to f by m, this is nothing but eq by m. eq by m. Therefore now we will use v is equal to u plus at if it is a time. If it is a displacement, yes, v square minus u square equal to 2as. Again substitute the values of u and a. Now you tell me whether, maybe for most of the students they appear to be again list of formulae, new formulae, memory. No memory. The same understanding of motion. Kinematic equation now I am writing. So velocity gained by the particle, v is equal to u plus at, I already told u is equal to 0. Therefore v is equal to acceleration times t. Therefore the result is, of course, you have acceleration means eq by m times p. This is the velocity. And of course, if it is a displacement, v square minus u square equal to 2as, v is equal to under root 2a, yes. Now the symbols should not be confusion. Suppose if I call it as a small v, okay, doesn't matter, v small or capital, v is equal to root of 2as. Because why means, because sometimes we will come across another v in electrostatics. So to not to have a misconception or a confusion between, I am using small v for velocity, root of 2as. What will be this expression? Yes, it is under root 2 times, yes, eq numerator, numerator is eq as denominator is f. Denominator is f. So what will be the velocity gain? Maybe in the direction of field or opposite to the field. We got the expression for velocity. Once we know the velocity, we know the mechanical energy that we can write for the particle into motion, which is kinetic energy. Now you tell me whether all these things are in a simple sequence or it's a memory. We know acceleration, therefore velocity. We know velocity, therefore kinetic energy. All these things, whenever you require, you can do it within 5 to 10 seconds. That should be your practice. I always expect from you, right? Now this is what is velocity. Velocity we got expression. Now let us take what is kinetic energy. So kinetic energy means here half m v squared. Therefore velocity expression I will use. Therefore now the kinetic energy gained by the particle. Remember this is the case of particle released with no initial velocity and then it is complete gain of kinetic energy. So kinetic energy is half m v squared. Again we will have two expressions for this because in terms of time, in terms of displacement. If you write, substitute the time equation, what is that? V squared, e squared, u squared, v squared, this is m squared. And this is half m is there, one m gets cancelled. Right? So what is that we get? E square, q square, t square by 2m. This 2 term is there, m square and this m, right? Cancellation. You will get e square, q square, t square by 2m. And now you also have the other expression. What was that? V is equal to, yes, remember we said that it is under root 2a, yes, which is under root 2eq, yes, for the displacement symbol I am using, by m. Then if you square this, 2 gets cancelled, m gets cancelled, then you have this expression is E times charge times displacement. In this entire expression, what you will find that the same kinematic equations, where we have substituted only one thing. There, acceleration is equal to dq by ma small change. So this is what is the kinetic energy gained by the particle. Now let us come to the other topics. Now this is the case we said, placed initially without any velocity. Now let us come to the concept of a particle, charged particle projected in an electric field. I am telling you, there also the same concept. What is the force? What is the acceleration? And hence, what is the velocity and what is the other aspects like kinetic energies and all. Right? So if you are ready with this practice, do it time and again. 1 time, 2 time, 3 time. After that, tomorrow's class we will have more elaboration on the charged particle projected in the electric field. Till that moment, eat well, sleep well, prepare well. Good day, thank you.